to predict the effect of the mutation. The software is named Polyphen 2. So in the Polyphen 2, the prediction is based on a number of sequence, phylogenetic and structural features characterizing the substitution. And for a given amino acid substitution in a protein, Polyphen 2 extracts various sequence and structure-based features of the substitution set and feeds them to a probabilistic classifier. So, okay, so let's go to the Polyphen 2 software. Just type Polyphen. Okay, the first one is the software. And for the querying data, you can input the protein identifier, and the supported database of for example, protein database UniProt-KB or referencing the NCBI or ensemble. And also you can input the protein sequence in FASTA format. So how to find the protein identifier of a gene in a protein database? Okay, so okay. For example, let's go to the protein database UniProt. Okay, the UniProt. Okay, the first one. And for example, for the gene that I mentioned just now, PTS, you just type the name of the gene here. Okay, so you can see it didn't show you the genes which names is PTS here, and it shows you all the items that contain PTS. So we need to specify that the PTS is the gene name. Okay, here the advanced. Go to here and specify the term you are searching for is a gene name. Okay, so then you can see here this one, and here is this one is the protein ID of the gene P. Let me check. Okay, yeah, this one, PTS. Okay, here is the protein ID. Okay, then you put here. And here you need to input the position that the mutation occurred. So then you need to, here are some basic information of this protein. And then you need to go to here, all the set menu. This one, the sequence. Okay, now here are the sequence of this protein. For example, we assume that the amino acid at the 80 position. So here we enter 80, and we see that at this position, the amino acid is M, is labeled M, and then we click here, the original amino acid is M. And the second one you show, you select the amino acid that is the mutated amino acid, which means at this position, the M mutated into K. Okay, then you click submit. Okay, may need to wait for a minute. Okay, the result is okay, it's ready. Okay, here it shows you the detailed information that you entered just now, the protein ID, the position of the mutation, the original amino acid than the mutated amino acid. Okay, when you put your mouse here, it will show you the model it used to evaluate the mutation. And there are three kinds of result, damaging or benign. Damage or benign too. Okay. And if the color is, if the value is close to 1, it means it have a high probability that this mutation is damaging. And if the score is close to 0, it means that this mutation has a high probability to be benign. Okay. And this is the result of when using another model. Okay. And similar as SIFT, and it also used perform multiple sequence alignment using the protein of this protein in multiple species. And you can see at this position, the protein in many species at this position is M. And when you make the M mutated into K, it will cause some damage because you can see K is not found in the other species. And as you can see, some species have I at this position. So we can try that if we, for example, we at this position, the original amino acid is M, and then we set I as the mutated amino acid, and you can guess what is the result. Okay. Okay, see, this time is benign because at this position, there are many other species contain I at this position. So if we in, for example, in human, the M mutated into I, it will not cause some bad effect. So so the mutation is predicted to be benign. Okay. However, for this one, if the mutated amino acid is K, then the result is damaging. And here, maybe this result you can see is the same protein, same position, and also the M mutated into K. And this screenshot is I got several years ago, and at that time the result is benign. And now maybe they have already improved their algorithm, and you can see here the result changed, and this time is damaging. So when you're using the software to predict the effect of the mutation, you must be cautious, and you need to, it's better to use more than one software to evaluate the result. Yeah. And yeah, that's all for this software.